Hello everyone, welcome back to my channel. In this series, we are going to go through the most commonly asked React interview questions, the ones that actually come up again and again in real interviews, and we will break down clear, simple answers for each one. This is a video one, and we are covering React fundamentals in depth, JSX, components, props versus state, the virtual DOM, all the major hooks, common patterns like memoization and error boundaries, and a few performance and code splitting concepts too. If you are preparing for a front end React developer interview, this is exactly the kind of question you should expect in the first couple of rounds. So we have packed 30 questions into this one video. So we are going to move at a good pace. So let's jump straight in with the question number one. So what is React and why is it used for building UIs? So let's start right at the beginning. And this is the first question which you will expect in every React interview. So React is a JavaScript library, not a full framework for building fast component-based user interfaces. It was built by Meta originally for Facebook, and it's been around since 2013. The big idea behind React is that it's a declarative. Instead of writing step by step instructions for how to update the page, you just describe what the UI should look like for a given state, and React figures out how to make that happen. So on screen you can see the classic entry point. We import create root from React DOM client and call render with our app component to mount it into the page. If the interviewer asks why React, a good answer touches on reusable components, a massive ecosystem, and a strong active community. So that's really why it stayed so popular for so long. Second question, what is JSX and why do we use it in React? So JSX stands for JavaScript XML. It's a syntax extension that lets us write HTML-like code directly inside our JavaScript files, right inside our components. So here's the important part of an interview. JSX isn't something the browser understands directly. Babel compiles it into regular JavaScript, especially React.create element calls. You can see that on screen. Our simple h1 tag with a name inside curly braces compiles down into React.create element with a tag name, the props, and the children as arguments. So why do we use it? Because it makes our component code way very readable and declarative. And one thing worth mentioning, if we push further, JSX is technically optional, but pretty much nobody writes React without it because it's so much clean to read. So let's move to another question. What is a React component? So a component is a reusable self-contained piece of UI. Think of it like a function that returns markup. It can be as small as a single button or as large as an entire page layout. The real power of React comes from composition. We build small components and then combine them together to build up more complex UIs. Look at the card example on the screen. It's just a function taking a title drop and returning a div with a heading inside it. We could reuse that card component anywhere in our app. And just to round this out, there are two type components in React: functional components, which is what we just saw, and class component, which we will get into the next. So functional versus class component, what's the difference? So functional components are just plain JavaScript function that return JSX. On screen, you can see the welcome function. It takes prop as an argument and returns an h1 tag greeting the user to handle state or lifecycle behavior. Functional component uses hooks and like useState and useEffect. Class components, on the other hand, are ES6 classes that extend React dot component. They use this dot state for React and lifecycle method like component did mount. In this example, you can see the same welcome component written as a class using a render method instead of returning JS directly. For the interview, the key point is this: the functional components are shorter, simpler, and a modern standard, especially since hooks arrived. Class components still work fine, and we will see them in code base. But for new code today, in React 19, we almost use only the functional components. So, what is the difference between React and React DOM? So this one's a good one to know precisely. What is the difference between React and React DOM? React itself is the core library. It defines components, hooks, and all the logic around how your UI behave, but it does not actually know how to put anything on the screen. So React DOM is the renderer. It's the piece that makes our React component and actually mounts them onto the web page. On screen, we can see we import create root from React DOM client specially for that job. And here is a nice detail to mention: if we want to stand out, React Native uses the exact same React code but swaps our React DOM for a different renderer that targets mobile native views instead of the browser DOM. So the logic clear stays the same, only the render changes. So let's move to next one. The difference between props and state. And this comes up in almost every React interview. So props short for properties. As read-only pieces of data passed down from a parent component into a child, the child can't modify its own props. It just receives them and uses them to render something. State, on the other hand, is local data that a component manages internally. It's mutable, meaning the component can change itself, usually in response to something like click or an input. So look at the code example. The greeting component receives name as a prop fixed from outside, but it also has its own count state created with use state, which it update itself using set count. So data flows down through props while state stays private to a component unless we deliberately lift it up to the shared point. The next one: what is the virtual DOM and how does it help performance? So now a classic, the virtual DOM is a lightweight JavaScript representation of the real DOM, kept in memory. Think of it as a plain object tree mirroring the page without expensive rendering work attached to it. So here's how it works. When state changes, the React first update the virtual DOM, then it compares or dips the new version against the previous one. That process is called reconciliation. So React figures out exactly which nodes actually changed and only patches those specific nodes into the real DOM, not the whole page. Why does this matter? Because direct DOM manipulation is slow. So by minimizing actual DOM writes, React keeps apps fast even as they grow more complex. So what is the difference between the virtual DOM and the shadow DOM? So the virtual DOM, like we just discussed, is React's memory tree used purely for diffing and figuring out what changed so updates can be applied efficiently. The Shadow DOM is the complete different thing. It's a native browser feature, uh, part of the web component standard, so used to encapsulate a component's markup and style so they don't leak out or get affected by outer css. You can see on screen a raw example using attached shadow. That's a browser api, nothing to do with React. So the short answer for an interview will be they solve different problems. React relies on the virtual DOM for performance. So Shadow DOM is about style and markup isolation, and React doesn't use it by default. What are React hooks and why they were introduced? So hooks are functions that let functional components use state and other React features. So things that used to require a class component, they were introduced in React 16. The motivation was to avoid the complexity that comes with class components, things like confusing disbinding and messy patterns like high order components or render probes being stacked on top of each other just to share logic. So hooks let us reuse that stateful logic in a much cleaner way. On screen is a simple counter component using use state, one of the most common hooks. Others we will use constantly include use effect, use context, use ref, use memo, use callback. We are going to cover each of those in the next few questions. So next one, what are the rules for hooks? So rule first is only call hooks at the top level of our component, never put them inside loops, conditions, or nested functions. So rule 2 is only call hooks from React function component or from custom hooks, never from regular JavaScript functions. So why does this matter? Because React relies on hooks being called in the exact same order on every single render to correctly match up each hook call with its internal state. If we conditionally skip a hook, that order breaks and uh, uh, B gets subtle, and it will be difficult to debug the errors. And you can see the wrong and right on the screen. So instead of wrapping use effect in an if statement, you put the condition inside the effect itself. So and a nice practical tip will be install ESLint plugin React hooks, and it will catch most of these mistakes for you automatically. So next one is, what is the use state hook and how does it work? And this is one of the most used hooks in any React application. So use state is what lets a functional component hold and update its on local state. We call it with an initial value, and it gives back an array with exactly two things: the current value and a setter function to update it. In this example, counter start at 0 and set count is what we call to change it. Every click on the button calls set count with count plus 1, which triggers React to render with a new value. One detail worth mentioning to interviewers, state updates can be asynchronous. Always remember, state update can be asynchronous, and React often batches multiple updates together for performance. So we shouldn't assume state has updated immediately after calling this setter. It reflects on the next render. Okay, so what is use effect and how and when does it actually run? So this hook is used for handling side effects. So side effects mean anything outside of just rendering UI, fetching data, setting up description, manually touching the DOM, or setting timers. So by default, use effect runs after every render. Once React has updated the DOM, most of the time we don't want them on every render. So we use the dependency array. An empty array means it runs once we mount, and passing a value like ID means it returns only when that value changes. So that's one more key piece. The cleanup function, you can return a function from inside use effect and React calls it before the effect runs again or when the component unmounts. So this is very crucial for avoiding memory leaks like canceling a subscription that's no longer required. So let's next one, the difference between use effect and use layout effect. So useEffect runs asynchronously after the browser has already painted the screen. useLayoutEffect runs synchronously right after the DOM has been updated, but before the browser paints anything on screen. So always remember, use effect runs asynchronously, use layout effects run asynchronously, and it will run right after the DOM has been updated. Okay, so because use layout effect blocks the browser from painting until it finishes, it is used pretty sparingly, mainly for things like mirroring an element size or position before the user actually sees it. On screen, we are using use layout effect to mirror an element's height with get bounding client. React and set the height and state before paint, so there's no visual flicker. As a rule of thumb, default is use effect and only reach for use layout effect when we especially need to avoid a flash of incorrect layout. What is the difference between use ref and use state? So useRef give us a mutable object that persists across renders, but and this is the key difference. Updating it does not trigger a re-render. Use state by contrast causes a re-render every time its value changes. So when would you reach for a useRef? Common case: assessing a DOM node directly, shorting a timer ID, or keeping track of a previous value between renders. Things we need to remember but don't need reflected visual on screen. In this example, we use input ref to directly call dot focus on an input element when a button is clicked. A classic DOM assess use case that use state just isn't designed for. So, what is use context and what is the context API used for? So use context lets a component read a value from the nearest context provider above it in the tree. So without that value being passed down manually through every layer of props, it's commonly used for things like themes, but currently logged in user or app by setting data that a lot of different components need access to at a different depths in the tree. On screen, we created a theme context, and inside our toolbar component, we call use context on it to read the current theme directly. Nice pattern to mention. You call often pair context with use state or user reducer, so we are not just reading shared data but also updating it from anywhere in the context tree. Next is what is use memo and when should we use memo. So use memo memoizes, basically caches the result of an expensive calculation between renders. It only recomputes that value when one of the dependencies you listed actually changes. In this example, we are shorting a list with an expensive sort function wrapped in use memo with items as the dependency. So that short only runs again if item itself changes, not on every single re-render of the component. An import and for the interview purpose, you can say use memo isn't something we should sprinkle everywhere by default. It has its own small overhead. So uh, so I would say it's just meant for a genius expensive computation, not trivial ones. So what is the difference between use callback and use memo? Use memo memoizes a computed value and use callback memoizes a function. So that's the basic difference. Use memo memoizes a computed value. Use callback memoizes a function reference instead. So both skip recalculating unless their dependencies actually change. So why would you need to memorize a function, mainly to prevent child components from re-rendering unnecessarily. If you pass a new function reference as a prop on every render, a memoized child component using React.memo will still re-render because from its perspective, the prop changed. On screen, handle click is wrapped in just uh, in use callback with id as its dependency. And here's a fun fact worth mentioning. In an interview under the hood, use callback of a function and depth is basically equivalent to use memo of an arrow function, returning that function with the same depths. So what is a use reducer and when we choose it over a use state? So, useReducer is an alternative way to manage state, especially when the logic gets more complex. It uses a reducer function, state, and action in new state out, which will look very familiar if we ever use Redux. About Redux, we will talk in the next coming chapters. So it really shines when our state transition depends on the previous state or when we are managing several related sub values together as one unit instead of juggling multiple use state calls. On screen, our reducers handles an increment action by returning a new count based on the previous state. So we create it with the use reducer, passing our reducer function and an initial state and get back state and a dispatch function to trigger those transition. It tends to make state updates more predictable and easier to test in isolation. So what are custom hooks? A custom hook is just a regular JavaScript function with one convention. It's the name. Its name starts with use, so that sit inside it. We are free to call other hooks like useState or useEffect. The whole paint. The point is reusability. Instead of duplicating the same stateful logic across multiple components, we extract it into one custom hook and just call that hook whenever we need that behavior. On screen, use window width is a custom hook that tracks the browser width using use state and use effect internally and return just the width value. Any component that needs to know the window width can now just call this one hook instead of rewriting the logic every time. So why does React need a key prop when rendering list? So here's the question that trips a lot of people up. When we map over an array to render elements, React needs a way to track which item is which across re-renders. Keys gives React that stable identity. So when the list changes, an item added, removed, or recorded, so React knows exactly which DOM needs to uh, update, move, or remove instead of re-rendering the whole list from scratch. So in this example, we map over a user's array and give each list item a key of user.id, a unique identifier from our actual data, not the array index. So that's an important detail to call out. Avoid using the array index as a key, especially if the list can reorder or have items inserted in the middle. So do that and React can mismatch items, causing bugs where the wrong row keeps stale state. The next one is what is a conditional rendering in React? So it's really just showing different UI based on some condition. The exact same logic we will use in the any JavaScript program, just applied inside JSX. The most common patterns are the ternary operator for either or cases and the logical and operator for show this only true case. Since JSX let us drop any valid JavaScript expression inside curly braces, so these patterns just work naturally. So on screen is logged in ternary between the dashboard and a login form and has error and an error banner. So one tip for cleaner code: if you find yourself nesting multiple ternaries, Together, it's usually clear to pull that logic out into a separate variable or its on small component instead. So next one is control versus uncontrolled components. So what's the difference? A control component is one where the form inputs value is driven entirely by React state, not managed by the DOM element itself. So you can see that in the first snippet, the input value comes from our name state, and every keystroke calls set name throughout on change. So uncontrolled component let the DOM element manage its own value the normal HTML way, and you read it using a ref when you need it, like in the second snippet using input ref with a default value. So for the interview, the practical takeaway control component give you full control validation on every keystroke, dynamic formatting, conditionally disabling a submit button. So that's why most production forms are controlled, uncontrolled. Ones are simpler and fine for very basic use cases. So next, what does lifting state up mean in React? So it means moving a piece of shared state up to the closest common ancestor of the component that need it instead of keeping separate copies of that state in each sibling component. Why do this? Because it lets sibling components stay in sync through one single source of truth. The parent holds the state and passes both the value and an update handler downs as props to whichever children need them. On screen 2, parent holds a value in state and passes it down to both input A, which can update it, and input B, which just displays it. This is a core React pattern for keeping data flow predictable, and it naturally set up the next question. We are going to cover prop drilling. Okay, so what is a prop drilling and how do you avoid it? So prop drilling happens when you pass data from a parent down to a deeply nested child, but the components in between don't actually need that data. So they just pass it along. As the tree gets deeper, this gets messy and makes refactoring painful. So the most common fix is the context API built into React on screen. We create a theme context, wrap our app with the provider, and pass the value down. Now any component anywhere inside that tree can access theme directly with use context, no manual passing required. So for larger apps, you might also reach for a dedicated state management library like Redux. Redux is the common, and we have a just stand as well. And it's worth mentioning restructuring your components so children get passed in as props themselves through composition can also reduce how much drilling we need in the first place. So the next, what are React fragments and why use them over a div? So a component can only return a single root element. So if you have multiple sibling elements to return, normally we will wrap them in a something like div. And but so that's add an extra often unnecessary node into your actual DOM. A fragment solves this. It groups multiple elements without adding any extra node to the DOM at all. You write it as a React DOM fragment or just the shorthand. Just empty angle brackets opens and close. So on the screen we are returning two TD elements wrapped in the shorthand fragment. This is especially important inside table rows. If you wrap those TDs in a div instead, you will actually break the table's expected HTML structure since the browser expects TDs to be the direct children of a TR. So next question, what is the children prop in React? So props.children represents whatever context is nested between the components opening and closing tags. It can be text, a single element, multiple elements, or even a function. So this is what let you build flexible, reusable wrapper components, things like a car, a model, or a layout, where the outer component doesn't need to know exactly what's going to be rendered inside it. On screen, our card component just renders whatever children get passed into it, wrapped in a div. So we can use that same card component with completely different context each time, heading and a paragraph here, something else entirely somewhere else. So this is composition, one of the most powerful patterns in React. Let's move to another. What is React.memo and how does it help performance? So React.memo is a high order component that memoizes a component's rendered output. It keeps re-rendering the component of its prop haven't if the prop hasn't changed, using a shallow comparison. So this is useful for components that renders often but usually receive the exact same props. You avoid a wasted work of re-rendering something that would look identically anyway. So on screen user card is wrapped in React.memo, so it's only re-renders when the user prop actually changes. Uh, so in an interview, we can say React.memo isn't a silver bullet. Overusing it on components that change frequently anyway just adds extra comparison overhead without any real benefit. What are high order components? A high order components is a function, so that takes a component as input and returns a new enhanced component. It's a pattern for sharing reusable logic across multiple components, things like authentication checks or logic. So that's a naming convention worth knowing. High orders components are usually prefixed with the with like with auth or with logger, which is exactly what's shown on the screen. So with logger takes a wrapped component and returns a new function that logs something, then it renders the original component with all its original props spread through. Uh, so in an interview, we can mention HOCs are largely a legacy pattern now. Modern React tends to reach for custom hooks instead to share this kind of logic, but you will still run into high order components in old code bases. So it's worth recognizing the pattern. So what are error boundaries in React? So error boundary is a component that caches JavaScript errors anywhere in its child component tree, log them, and shows a fallback UI instead of letting the entire app crash to a blank white screen. So they are implemented using class component with two specific lifecycle pieces: get derived state from error, which update state. So the next renders show a fallback and component it catch, typically used for logging the error. On screen, our error boundary tracks has error in state and renders either a fallback component or its normal children based on that. One detail that catches people out in interviews: error boundaries do not catch error inside event handlers, asynchronous code, or errors during server side rendering. They are especially for errors during rendering. So, what are React.lazy and Suspense used for? So React.lazy let you dynamically import a component so it gets split into its own separate JavaScript bundle instead of being bundled with everything else upfront. This component only gets downloaded when it's actually needed. So Suspense is what handles the loading state. It shows a fallback UI like a spinner, while that lazy component is still being fetched over the network. So on screen, we create a profile using React.lazy with a dynamic import, then wrap it in Suspense with a spinner as the fallback. This pattern is commonly paired with route based code splitting. So each page of your app only loads the JavaScript it actually needs, so which can meaningfully shrink your initial bundle size. And that wraps up all the third okay. So in this chapter we cover 30 questions. We covered React fundamental questions, everything from JSX components, hooks, performance patterns like memoization, error boundaries, high order component splitting. So if you uh, like it, then please drop a like, subscribe, subscribe for this channel if you haven't already, and let me know in the comments which interview question I should cover next. So in the next video, obviously I'm going to talk about state management, performance, Redux versus context. So thank you for watching and see you in the next video.